Okay, so this lesson, 16.1, is going to build on some of the stuff we talked about last week when we talked about exponential equations. So last week, remember, we would have an equation that would say something like y equals 3, I'll use different numbers, 7 times 1/4 to the x. And the things that we learned last week were that this first number is our starting value. This next number is going to be our pattern. Remember, if the number is bigger than 1 or a whole number, the pattern is going to be multiplication. So if we have, like, for example, a 2 or a 7 or an 8, whatever here, that's going to be multiplication. And then if our number is a fraction or anything less than 1, like a decimal, that's going to be division. So for instance, 1/4 is division by 4. So that's just a reminder from last week. Today we're going to talk about how to solve equations. So if you notice in this example A below, what they've done is they've given us an equation, but they've set it equal to something. And basically what they're trying to ask us is, if I make a table of values like I would use to graph, when will I hit this value, this target value of 96? So the idea is that 96 is my target number. So the same way we did last week, I'm going to start by making my table of values. My starting point is 3, and remember, mathematicians start counting at 0. And my pattern's a whole number. That means moving forward, I'm multiplying by 2. Moving backwards, I'm dividing by 2. So if I'm trying to get to 96, I want to be going forwards because multiplications, that's going to get bigger. That's the only way I'm going to get to 96. If I go backwards, I'm going to be trying to get decimal numbers. So I'm going to just kind of make myself some room here. So if I multiply by 2, that's going to give me 6. And then I'm going to do that again. 12, 24, 48, 96. Now you may have to use a calculator, especially when the numbers get more difficult. But we've reached our number 96. And so the answer for x is really this value at the top is when did I get there. And if I fill in the top of the table then, 1, 2, 3, 4, 5, that means I'm going to get to 96 when I hit the 5th term or the 5th value of x. So the answer to this equation is x equals 5. And the reason we write it as x equals 5 is because, remember, the top of your table is always your x values and the bottom is always y values. All right, this is our only other example for today, but we're going to be spending some time in word problems this week. And don't freak out on me about that. A lot of times people think that these word problems are actually easier than any of the other ones that we do all year long. But because we're only doing one problem, I want you to have good notes. So you do need to make sure that you copy down this problem into your notes. Okay, so what we have to do now is take the information that they've given us and write an equation like the one that we just solved. So just like we wrote before, if we're going to write an equation, we need to know, if nothing else, we need to know the starting value and the pattern, or what they're calling now the growth rate. All right, so my starting value, if you read this, currently it says it has 2,000 elk. So my starting value is 2,000. It's increasing at a rate of 8% per year. So this is very important for you to know. Anytime you have percentages, you have to write them as decimals. So remember, 8%, when I go to write that as a decimal, I have to move the decimal place 2 times. So that's the same as saying 0.08. And now, if you take a second to think about 0.08 as it stands, that right there, if I tried to use that in my equation, that number is less than 1, right? That's a fraction, which means my values would actually be getting smaller. But it says it's supposed to be increasing. So to fix that, what we do, and we'll spend a little bit more time doing this tomorrow and throughout the week, but to fix that, instead of just putting 0.08, we call this 1.08. That's going to mean we get to multiply to make the value bigger instead of divide. So before I even talk about answering the question, I want to write my equation. So I'm going to have y equals, all right, we got 2 spots, remember, my starting value, which is 20,000, and then my pattern, which now my pattern is a percentage, 1.08. And if I were taking notes, you may want to just make a note to yourself that this is the pattern, but it is also the percentage. Now, in this specific example, they actually tell me what the population is that I'm curious about. They say the population is 40,000. You could have known that even if they hadn't given you that number, it's saying doubled, so that's how you know what value they're talking about. So the ending population is 40,000, which means they want me to solve this question. 40,000 equals 20,000 times 1.08 to the x. Okay, now to solve that, we're still going to go with the table. At some point, I may show you another method just to maybe make some of the numbers easier, but for right now, we're going to start with our table. And our starting value is 20,000. Why did I do that? 20,000. And remember, our pattern going forward, we want it to get bigger, so we're going to multiply by 1.08. And we would go backwards, we would have to divide by 1.08. Remember, we don't want it to get smaller, and actually going backwards would take us into negative years, so we need to go forwards with 1.08. So since that's kind of an odd number, I'm going to pause and let you use the calculator on your phone, or I'll use the calculator for us, and we can get our table of values so that we can continue answering this question. Okay, so all I did was I took my calculator and I just continued to multiply by 1.08 every single time. And when I did that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like somewhere between 9 and 10 years is when the population doubles, but it's really, really close to 9 because I'm looking for 40,000. So my final answer to this question would be that the population doubles somewhere very shortly after 9 years. And because these numbers kind of get so crazy, and it could be that we have to do the pattern a lot of times over and over again, what I'm going to do tomorrow is show you how to use your graphing calculator to make this table. So if you will, put a big star in your notes next to this example and that says graphing calculator, so that you remember we should be doing this in a graphing calculator probably instead of just multiplying over and over and over again. And we'll show you how to do that tomorrow.